So now that we've talked about the first two layers, let's talk about layer 2 switching. First, let's start by talking about what a switch is, right? And a switch is a central connecting device, as we detailed earlier. And switches use MAC addresses to establish point-to-point connections, right? So what that means is that if we, for example, have device A and it wants to send data to device B, it can send that data directly. Okay, it does not have to broadcast all the information to all the devices that happen to be connected to the switch. And that's really important for security's sake, right? If we want to establish point-to-point communication, you should have the ability to do so, and switches allow us to do so. Right? Now, hosts connect to switches by plugging Ethernet cables into its ports. Right? And one cool thing to note is that every single port on a switch has its own or is associated with its own specific MAC address, right? So when a device is connected to a switch, that port on the switch is associated with the MAC address of the device that's connected to it. All right, so we talked about what is a switch, but what is a layer 2 switch specifically? A layer 2 switch is the most common type of switch that is used on a local area network. And like I mentioned previously, they direct frames on the local area network based on the physical or the MAC address, right? And each port is mapped to the MAC address of the device that is connected to. Now, I'm being a little bit redundant here, but it's pretty good information for you to know. All right. Now, we also talk about virtual local area networks as well. And the layer 2 switch allow for virtual local area network implementation. All right. And there's a standard here that is involved to support the virtual local area network, or we just call it the VLAN. And that standard is 802.1q. And as I mentioned in the previous modules, what happened here is that data frames are sent and then tags are added so that the only computer that received the information are the computer that are specific to the VLAN. Now you may be wondering, how does switches remember MAC addresses? Well, switches have memory that is dedicated to remembering these addresses, right? And switches are just going to map the MAC addresses to the connected computers and their ports, all right, in something called a content addressable memory table. We call it a CAM table, right? And the memory of a CAM table is really limited, right? And people can really take advantage of that fact, the fact that switches store addresses in their memory. What they do is they constantly send MAC addresses and flood the switch, and really it makes the switch inoperable. So keep that in mind. All right, so layer 3 switching is a little bit different. Layer 3 is the network layer. It controls the operations of routing and switching, and it translates logical addresses or names to physical addresses, or vice versa. So if you're receiving data, you're going from a physical address to a logical address. Now, a major protocol that we're going to learn about today is called the IP protocol. It's a network layer protocol, and devices that work on the network layer are routers and layer 3 switches, which can also be called IP switches. Now, there's a few different network layer components, right? You got IP addresses, you also have subnets, which we featured in our last modules, and the unit of measurement here is called a packet. Now, layer 3 switches are different from layer 2 switches. Okay, because they direct data using IP address instead of a MAC address, or what we call it a physical address, right? So they form packets instead of frames, right? They can perform all the same functions as routers, but they're not routers. They're not actually routers. The benefit here in using layer 3 switches versus a router is that they can actually forward packets a lot faster than routers. All right, so let's move on and talk about the upper OSI layers. All right. Now, layer 4 is the transport layer. And the transport layer ensures that messages are delivered error-free in a sequence with absolutely no loss. right? Now, there are a few different protocols that work at this layer. They segment messages and ensure that correctly assembly occurs, right? And they do something called message acknowledgement, which is sort of like a certified mail. The protocols are also responsible for traffic control. Okay, now within the transport layer, you have both connection and connectionless protocols. Okay, now with connection oriented protocols, they require that both devices involved in communication establish a logical connection. So it's like, hello, I'm a PC, and hello, I'm a server. All right, we've established communication. Now, this is considered, I guess you would call, a reliable network service because you have established communication. And if you're doing this in person with two people, you would know the other person, you would know who they are, and all of a sudden they become more reliable, right? And so if I'm a PC and you're a server, right, I'm going to say to you, hey, I'm sending you something very important. And you're going to acknowledge and you're going to say, well, I'll let you know when I get it. So if that important data sent by the PC and the server doesn't get it, all of a sudden the server says, hey, resend that data. And of course, the PC will resend the data. All right, so let's talk about connectionless communication. Now, every packet that is sent has a destination address in the header, right? And really all that happens with connectionless communication is that packets are just sent one after the other, right? There's no guarantee that they'll reach their destination and no guarantee that you'll know to resend them. So, a little bit different here. The example where a PC is saying, hey, I'm sending you something important. And of course, on the other hand, you have the server that's just sleeping at the wheel, right? So we're going to send packets in a stream, but there's absolutely no guarantee that it's been received. The connection-based protocol is TCP, or Transmission Control Protocol. It's a reliable byte stream service, and you're going to see this being used and leveraged by email applications and other protocols like FTP, where you need to download an entire file guaranteed. All right. In contrast, a UDP is connectionless, it's unreliable, and you're going to probably see this if you're streaming a movie or streaming some kind of audio. As I mentioned, if you're web browsing, you're probably going to be using TCP, right? If you're streaming media, you're probably going to be using UDP. Now, TCP is usually used for one-to-one communication, and UDP is often used for one-to-many communication, as in like a broadcast or a multicast. Now, a broadcast, of course, is when your device wants to send communication to all the devices on its local area network. And a multicast is if you want to send that data to just a few selected devices on your local area network.